So good morning, everyone. So before we begin, have a look at the screen of these companies' organizations. So what they all have in common is that they, among others, all use Neo4j. I'm not claiming that any of them that they are vulnerable, but that they do use Neo4j. And I'm here today to talk about it and what you need to keep in mind if you encounter Neo4j or if you're using Neo4j. Neo4j is the most common graph database. It is used in every industry all over the world. And I am Nitay Bachrach from Reconnaissance. I am from Tel Aviv, but I travel a lot, so you might encounter me anywhere. I'm a cloud security researcher, but also I have a lot of experience in many other security fields. But I'm here today to talk about Neo4j. So Neo4j is a graph database, and I will talk about Neo4j and Cypher, which is its query language, kind of like its SQL. I will explain how to execute and how to do Cypher-injections, but then I will also explain how to use Neo4j as a hacking tool. Because Neo4j is a database, and attackers can retrieve data, but they can actually do a lot more. They can get out of the Neo4j database into the target's environment, into the cloud, and they can also retrieve secrets that are not necessarily stored in the database, but they can access them using Neo4j. And as I said, Neo4j is the most popular graph database. But what is a graph database? So a graph database is a NoSQL DB, where we, instead of having tables like RDS, like the relational databases, we have a graph where we have nodes and edges that connect them, and that's how we represent data. This is kind of like how you would do it, how you would sketch RDS on a whiteboard, and it's used in many different fields. For example, I think a very obvious one would be social media, but also security. I'm sure many of you have heard of Bloodhound, which uses Neo4j to store data, or if you attended a very interesting talk yesterday about the CCD guard. It's a very cool tool that someone here wrote, and he uses Neo4j. It's a very, very common security. And in Neo4j to retrieve data, we use Cypher. Cypher is it's a query language. It's used also in other databases, not only Neo4j, but Neo4j basically they wrote Cypher and they manage it. It's inspired by SQL a lot, and also according to them ASCII art, because you have like rounded brackets, so they make circles, and this is like the nodes, and then you have arrows and lines, and that's how you represent what you want to retrieve. Of course, Cypher is not only for like retrieving data, you can also store and modify the data and do a lot of other things. It has many features, and we will go over them just to like make sure to understand what Cypher is before we talk about more advanced attacks. So in Cypher, like SQL, we need to be able to filter data. I can retrieve like a subgraph or like a specific node, but maybe I want only like nodes that meet specific criteria. So like in SQL, we have where. This is very, very similar. We can also like do things like OR and call functions. But we also have, we can do it directly in the match clause, which is sort of like the equivalent of select. And I can just tell it to only retrieve nodes or relationships that meet the specific criteria. It's very convenient. It's more, it's less powerful. Like, for example, I can't do OR or things like that. I can only tell it I need fields that meet this like the field with this value or things like that. But the developers use it a lot because it's very, very easy to use. And we, for example, attackers that try to attack applications using Neo4j need to keep it in mind because the injection would be different. another thing they learned from SQL is parameters. In Neo4j, in Cypher, and every other DB that uses Cypher, we can send parameters separately from the query itself in a secure way. So parameters cannot be executed, and then there is no injection. Now, not everything can be a parameter. For example, label. A label would be a species, or field names, like here the field name is name. They can't be parameters. That's how Neo4j works, that's how Cypher works. And because of that, and many other reasons, developers don't always use this feature. And that's why some applications are still vulnerable. One more thing we need to understand about Cypher is functions and procedures. They extend what Cypher can do, what Neo4j can do. And we can also use plugins to register even more functions procedures. And both of them, they are pretty similar. There are some key differences that we must understand. Procedures can only be called using a special statement. We have seen match, we've seen return, and now there is a statement called call, and that's how we call procedures. They usually generate data, and they can return many different rows and columns. And they can, for example, we can use them to get information about the DB. For example, list all the labels in the DB. Functions can be used anywhere, and they always return a single value. Usually we use functions to change or modify data. For example, here we just convert a string to an integer. But of course, many other functions, many other uses. And now we know what Cypher is. Hugo the Hedgehog really wants to talk to you to explain how to do Cypher-injections. So, when we talk about Cypher-injections, there are a lot of similarities to SQL injection, but there are some differences. For example, we need to keep in mind the idea that there is also like a where, but also a match, and it kind of changes the syntax. Also, very similar is the fact that we need to understand what the application expects the value to be. Is it an integer? Maybe it's a field. Maybe it's a label. So let's look at some examples. These two queries are basically identical in terms of what they do, but the injection would be different. Also, notice how I used a double quote in the first one up there. This is something that is very common in SQL. In Cypher, it's kind of like Python, unlike SQL. So I think many of you, like the pen testers, the red teamers, when you try to like hack a web app, and then you add a single quote and look for errors. So if they use Neo4j, you also need to check double quotes. Would also use backticks, because sometimes that's how you get them. Here are some more examples. We will look at them like later, but what I want to see, you see how like the first one, the where, looks pretty much like SQL. We have I added or1 equals 1 to make sure that I still get data. But when it's a match, it's a little bit different. I had to add the union there and return 1. And that's because if the match doesn't return anything, if there is no data, then Neo4j wouldn't run our payload. So whatever we're trying to do just won't run. And there is no OR. So that's how we get it to still return data. Here I added match. It doesn't have to be match. We can call a procedure directly. And also other statements that we will look at and discuss later. And now to understand that, we have an injection. What do we do? Well, a very important statement that I haven't mentioned so far is load CSV. Load CSV is a built-in statement that lets us retrieve CSV data. It's quite famous if you ever read or heard about Cypher-injections, that I'm sure that they mentioned load CSV. It can read CSV files from the file system, and it is usually disabled, or at least limited to a specific folder. Now, I have seen cases where I was able to read any file, but it's quite rare. More interesting is its network capabilities. You can use load CSV to send HTTP requests and get load CSV files from any HTTP server. And this is really useful. because we can do it to send HTTP requests, which means we can send data to our server. And that's how we can exfilter data. So even if it's a blind injection, we don't really care about it. We can just tell Neo4j, send it to our server, and we can just put whatever data we want to retrieve in the URL path, and that's it. We get the data. Network cannot be disabled. Of course, there is an undocumented feature that we are actually helping Neo4j to secure, which will let you in the future restrict IPs, but right now it's still not ready for production. You can use, of course, use a firewall, and I would recommend it to restrict like Neo4j, so it would only be able to access things that it needs, and not any server, but most don't really do it. So this is what an injection would actually look like. If I found an injection, the first one would be load CSV. So I do like the union thing that I talked about to make sure that there is data, and that Neo4j even like make sure that it runs our payload. And I use load CSV. Attacker.com is my server, and then I added as L. That's because in Neo4j, if you use load CSV, you have to store the response. Personally, I don't really care what the response is, but you have to store it. And then I call it a ping. I just do it just to make sure that my injection works. And now that I know that I have an injection and I can make it work, I can do whatever I want. I can, for example, call other procedures to list all the labels in DB, and then I can learn a lot about the database. I can exfilter data. If I know what the query is, or if I don't, I can just use match to get whatever I want, and I can just send the data to my server. And of course, we can even change load CSV together to get this like SSRF, a server-side request forgery, where we make Neo4j call servers, maybe even internal HTTP servers, and send the response to our server. One thing you need to keep in mind if you ever use load CSV doesn't really handle URL encoding, which means that it might send invalid requests that most HTTP servers would drop. This includes many HTTP servers that are used by attackers, ngrok, and others. If you use ngrok HTTP and not ngrok TCP, and also burp. Of course, it's not really a problem because we still get the packet, we get the request. So what I do is I just have like an HTTP-like server that still sends 200 OK, even if the request is invalid. And then I can still get the data and everything works. So the first thing I always do is reconnaissance. I always start with understanding the Neo4j version. There are two common versions, actually three, but one of them is very rare. The most common one is Neo4j 4. It's LTS, but there's also Neo4j 5. There are some key differences in the way we interact with them, so only like specific things, so it's always important to understand what we are dealing with. And then after I get the version, I can get the labels, I can also get the relationships, in order to understand what the database is, what kind of data is stored there. And then I would also want to list all the install procedures, install functions. This one, for example, is a little bit different in Neo4j 5, because they removed the procedure, and instead we have show, which is kind of tricky because we cannot inject it. It has to be run like independently, like separately from any other queries. We will explain later how we deal with it. But before that, some interesting tricks. So the one with count, I always edit, and there are two things I'm trying to achieve with count. So the first thing, for every row we retrieve, Neo4j would run our payload. And some databases are really big. There could be billions of nodes. So that would be billions of requests, and it's not going to work. And with this thing, it solves it. It's only one row, and that's it. The payload runs only once. Another thing is unknown variables. I showed earlier, I have to store the load CSV response. I call it L. But what if the query already uses L? The Neo4j wouldn't work. It just, the query wouldn't run. And this is just cancel all unknown variables and just solves it. And that's it. You're good to go even if you don't know what the query is. Another really cool trick is in Neo4j, we can also add Unicode characters. It's kind of like Python or JavaScript. We use /u and then 4 hexadecimal digits. But for some reason, Neo4j parses it before it passes the query itself. So, for example, if I run the query here, like where there is one single quote and other one is /u0027, which is the Unicode representation of a single quote, this is a valid query that Neo4j would run. And this is a way, like this way, if they have like, if they're trying to sanitize clean user input and they just remove single quotes or double quotes or whatever, we can just add this, and that's it. We are good to go. Also, it's a very useful way to circumvent most paths. Like for example, basically everyone I tried, and because I'm just not aware of it. They all look for the single quote and then an OR, but if it's /u0027, they have no idea what they're looking at, and that's it. You're in. And now I want to talk about something awesome. Awesome procedures on Cypher, APOC. APOC is an extension for Neo4j. It's very common. It's ubiquitous. It's everywhere. Almost every server I encounter had it installed. It is maintained by Neo4j, and it adds a lot of functions, a lot of procedures that just make the lives of developers easier. They add a lot of capabilities. And making the lives of developers easier also means making the lives of attackers easier. I'm sure that everyone here would agree. So, some useful APOC functions and procedures are APOC convert to JSON. So earlier I showed how I can exfiltrate data, send data to my server, but in order to append it to the URL, it must be a string. But what if the data is not a string? What if it's a list, or even a graph? So APOC convert to JSON doesn't care what it is. It converts everything to a string. We can also use APOC to run Cypher queries. And that's how we solve the show procedures and show function problem that I mentioned earlier, that must run independently. We can just use APOC to run show procedures or show functions if it's installed, and almost always installed. And then we can get the list of procedures, list of functions, and a lot of data. We also have APOC Cypher run. Those are procedures. They're pretty similar, except to the way that you call them. But even more interesting is the load CSV params and load JSON params. So earlier we saw load CSV. And does anyone here understand what the biggest limitation of load CSV is? Maybe you were able to guess it. Well, we can only do GET requests, and we cannot control the headers, and also not the payload. And if I really want a very powerful, strong SRF, and I really want to get into the target environment, maybe I need a post request, maybe I need a put, maybe I need to control the headers, maybe I need to send a payload, data. And that's what these procedures, that's what they can do, which makes it way more powerful. Another cool one is APOC run many, which is very similar to the other APOC Cypher run, except that it creates a new transaction. And now, before I explain why it's interesting, let's talk about getting the query. Knowing what the query is, if we are injecting, is very useful. If anyone here has ever used any kind of like SQL injection or any other kind of injection, I think it's very obvious why knowing what the query is useful. But if you don't, so if we know what it is, we can affect the execution, the flow of the application, because we know what data it wants to return, we know how to return it, and now we can basically just change. For example, if it was an app that is retrieving a user and some like fields about the user, we can change the role from user to admin. And now we know the queries, we know what it expects, we can easily do it. In Neo4j 4, it's pretty trivial. there is a procedure, list queries, and it gets information about all queries, including the one that is running right now and we are injecting into. In Neo4j 5, we have show transactions, and it only returns the currently running query. So if I use APOC Cypher run, which doesn't create a new transaction, it would return show transactions, which is not an interesting query. It's the one I called, and there's no data there. But because run many creates a new transaction, it would return now 2 rows, show transactions, but also the one that called it, which is what the application actually called, and that's how we can get the query. So now let's see. Before that, let's summarize. As attackers, if you believe there is Neo4j, try a single quote like you would in Cypher-injections, but also a double quote and also a backtick. And also try the unique alternatives, which is immensely powerful. Also keep in mind match. Always try to get a ping, which is just to make sure that your injection works. And get the Neo4j version and try to get the Cypher query. Now let's see it in action. So this is a web app that is vulnerable to Neo4j that I wrote. And this is burp. And now I have the Python server here, which is an HTTP server, sort of, that just doesn't care about invalid requests. And now if I... Pretty trivial, kind of just like a SQL injection, I get an error. So this is an indication. This is probably something is going on there. So let's see. Here, I'm trying to do the ping. I know that Hugo is a valid, it works because of 10 data, so I don't need to do all, or match, or union, or whatever. All I need to do is to call load CSV. And, wait. Nothing. So maybe it's a match clause. So let's close it. And we got a ping. So now, what's the first step, would be? Well, getting the version to see what we're dealing with. This is of course pre-recorded, but... So we have DBS components. It's a procedure that we saw earlier. It returns all the data about Neo4j. And then we just append the fields it returned to the URL. So let's send, and we know now it's Neo4j 5, specifically 5.30, Community Edition. Okay, so if the next step would be getting the procedures, and it means that we need our APOC. So we hope that APOC is installed. As I said, it usually is. We run it, and we see a lot of procedures. A lot of APOC procedures, and also some built-in ones. And if we look at them, we can see, for example, we have load, JSON params, we have load JDBC, a lot of interesting procedures here. Some of them, procedures that we mentioned earlier, that are very, very powerful. And also very common. And now let's see what the query is. So I use run many, because otherwise I would get only show transactions, which is not very interesting. And we got 2 results. Why? Because we created a new transaction. So the first one is a show transactions, the boring one, we don't really care about. But the other one is the query that called it. And now we know what it is. For example, here is the payload, but everything around it, this is what the app sent to the server. So we can see here, it expects one variable, one value called count. And we can also see that it's supposed to be an integer, because it uses the function count. And the function count, if we look it up, it always returns an integer. So now that we know that, we can easily, for example, here change the number to whatever we want. And if it was a more interesting app and not just a demo app, we could have done like even more interesting things. So we just do return 1337 as count, and we can control the results. But now what? It can't be it, right? So let me tell you, this talk is not about injections. It's about Neo4j and how to use it as an attacker, and also for the defenders could really understand what the implications of using Neo4js are and how to use it in a secure way, which is possible. Neo4j is great, I use it a lot, but just we need to be aware of what it means, what an attacker could do with it. So most Neo4j servers, like everything today, is usually in the cloud. And if you're in the cloud, let's get cloud credentials. The most common cloud is, of course, AWS. There's also like GCP, Azure, but they're pretty similar. In AWS, all virtual machines or EC2 instance, they have a dedicated HTTP server. It's called IMDS, the Instance Metadata Server. And this server it has a lot of metadata, and it's including the credentials that the instance can use to access the cloud and cloud resources. This server is always 169.254, 169.254, also in Azure and GCP. And in AWS, there are two versions. We have IMDS v1, which is old, it's less secure, but it's still widely used. It's by far more common, because it is still the default. And it's less secure because there are no sessions, no special headers, even the simplest, any SSRF, and you're in. And that's why they introduced IMDS version 2. IMDS version 2 is more secure because we need sessions, headers, so simple SSRFs are no longer enough. So if it's an IMDS version 1, it's pretty easy. Two HTTP requests, only get. First, we need to call this URL here, latest metadata IAM security credentials. We get the role name, and then just append it to the URL, and we have credentials. So if it was in Neo4j, I know it's kind of hard to read. It's right now, it's not very important. You can also look at it later. There are 3 load CSVs here, not 2. And the reason is, the first one, we get the role. The second one, we get the credentials. The third one, we are sending the credentials to our server. There is a substring here with some numbers. Those are just the offsets of where the data is stored. That is because it returns a JSON, not a CSV. But as attackers, we don't really care. A developer wants everything to be parsed. Attackers just want to get the data. So if we ran it, we would get the token, the secret, and of course, the first one, the access key. And with this, we can access Neo4j, we can access AWS. But what if it's IMDS version 2? It's kind of interesting because I remember when I did my research, I read about Neo4j attacks, and many articles said that IMDS version 2 is secure. You cannot use Neo4j to get credentials. And I found out that it was not the case. And also it's the same if it's GCP or Azure, because they are pretty similar to IMDS version 2. A little bit simpler. So, let's see how we can actually do it. But before that, we need to understand how IMDS version 2 actually works. What makes it more secure. In order to do that, we need to ask an expert. The biggest expert, the one that knows all answers. We need to ask ChatGPT. So, how do we use IMDS version 2? Spare no details. And we see, nice, it's Python. So the first step, I know it's kind of hard to read. The first step is obtaining the token, which we do. We need a put request, and we need to have this weird header. Okay. Now we have a token. So now there is a URL, which is familiar, the same one we saw earlier, except that now we need to add the token as a header. Other than that, the same as IMDS version 1. Cool, we get the role name. We append it to the URL, and again, the same, kind of like IMDS version 1, except we need to add a header, which is the token that we just got. Okay, so we now we understand how IMDS version 2 works. And we have Python code that does it. But Python is not Neo4j, it's not Cypher. So let's see how we can do it using Cypher. We have the same app, same vulnerability. But now, we saw earlier that we have APOC load CSV params and APOC load JSON params. So let's use it. So, we can see here the same URL that ChatGPT wrote, getting the token. And here method, put. And here we add the header. We have header false here, which is kind of confusing. This is because it's a CSV. And now I'm telling Neo4j that my CSV has no headers, because otherwise it would think that the token itself is the header and just wouldn't return it. And that's a shame. So, we run it. And here we have the token, which is still not AWS credentials. It's only a token. But that's the first step. And I think it's not. Just a second. I have no idea why this is. Oh, okay. So this is kind of scary. Wait. We have a lot of data here, but it's actually not so bad. We call the second call that we saw in ChatGPT. And this time we added a token as a header. We have the metadata, YAM, security credentials. And now we're supposed to get the role name. So that's the role name. Let's just append it to the URL. And there we have it. Token, secret access key, and the access key ID. And those are not real. Completely fake. You can even see access key. And if you have good vision, good sight, you can see that the secret says secret in lit code. Of course, it's not real, but in real environment, we get the real access key, the real secret access key, and the real token. And then we are in. We can use the server's privileges, permissions to get S3 buckets to access secrets that are stored in the secret manager in AWS. We can use it to access code repositories. Whatever the server can access, we can also access. Freely. Nice, okay. But now a little bit some more. As I said, we can also get some secrets. A simple secret would be getting the hash, right? It's always nice. So in Cypher, in APOC, there is a procedure called systemdb graph. It's a special DB that we cannot usually retrieve and interact with. We can, but only using a specific set of commands and not normal ones. But using this procedure, we can get the entire database. And this includes the credentials. They removed it in the latest version after we told them that they have this problem. But in almost all servers, we can still call it, we can still get the credentials. The hash of the credentials that you can then just break. You can see it's SHA-256, 2024 iterations. And there is also the salt. I think more interesting are environment variables. Today in modern cloud solutions, there's a lot of secrets that are stored as environment variables. And we had the procedures config map and config list that just returned all the environment variables that are stored in the server. So this could include tokens to other cloud solutions, or maybe the ID that you need to access credentials. If it's not a simple instance, maybe it's ECS, maybe it's a container, then you need an ID. Maybe it's a password, because some people store the password as environment credentials when they need to use API calls. So this was very useful. They also removed it in the latest version after we told them that it's a security problem, but still most servers still have it installed like an older one, and you can still list the environment variables. Some more interesting procedures could be we can connect to SQL servers and also NoSQL servers. And I don't have a lot of time. Also, these procedures are not installed by default, or at least they are, but you need drivers. So they are not as common, but it's cool to check them. And any questions?
You're trying to research some ways to get persistency in the database?
Yes. There are ways to get persistency using if APOC is installed, unless they restart the server and then you lose it. But usually databases stay alive for a lot of time, and you do it because APOC supports periodic tasks. And then you can register a periodic task where you can just, for example, query some server, ask for a query to run, and you can just does it periodically, let's say once an hour. So yes, it is possible. Anyone else?
Thank you for the presentation. Are you going to share some type of script or tool that allows us to find these injections automatically, or be part of some kind of plugin such as SQL map or any type of tools like that?
We have an internal tool for that we wrote. Right now I'm not going to share the entire tool, but if you want, I can share some payloads and so many different techniques that we use there. Just come and ask me after the presentation. We are going to release a tool soon that can be useful if you want to defend your environment, because it can find misconfigurations, and it will tell you how to mitigate the problems.
Thanks.
Okay, so just some takeaways. If you're an attacker, always think about match or where, look for APOC, look for secrets. If you're a defender, you can restrict procedures and functions, and you can also, if you're using the cloud, adhere to the least privilege principle, and if it's AWS, use MDS version 2, always. Even if it's not Neo4j, always. Thank you very much. I'm Nitay, and thank you.